Hello again. Like I told you earlier, I wasn't going to show my face anymore so I could show you the pictures of Mars that I have. What you see before you here is again, these are some pages that are primarily out of another textbook that we used to use. I just like the pictures better. We're going to use some others as well. But I want to show you some things about Mars that we need to know about would make sense for us. Okay, first of all, Mars is a little bit smaller than the Earth, a little bit more dense, but the days are about the same length. So it's a little bit longer days. These two things, the fact that it's a smaller planet and also it has a smaller radius, or a less massive planet and has a smaller radius, makes the gravity on Mars much, much less. Pardon me a second. I want to make sure it's working. Yeah, okay. Sometimes I can't see these things properly. You should be able to see me. Okay, back to what I was saying. Focus. So the gravity on Mars is about 38% of what it is here on the Earth. That means that on Mars, somebody who weighed, say, 200 pounds would weigh 76 pounds if they weigh 200 pounds on the Earth, they weigh 76 pounds on Mars. Good way to lose weight. The Martian surface has the major feature here is the Tharsis Bulge, which is about the size of North America, and it's 10 kilometers above the surroundings, which means it's 10 kilometers above the mean surface of Mars. Doesn't have a lot of cratering on particularly the northern half of Mars, and we'll see that in the picture coming up. So here is a pretty good, I like this picture of Mars, and I like this spread here. This talks about how, or this explains how the different altitude of components of Mars are. This is about 0 would correspond, again, if you want to think about that, about what we call sea level here. Now again, Mars has no current oceans. Probably never did have like we do. But this region up here, it's blue, this is just a lot lower. This is like on the average of at least, from looks here, about 4 or 5 kilometers lower than the mean. So these areas here are very, very flat. And probably there was at one time some lava flows here, maybe some water at some point in the distance past. Now, these markings here where it says opportunity and curiosity, I might talk about those in a minute. But these are some robots we've sent up there, and we've looked around on certain things. The Viking probes here are where we had different landings. Pathfinder was as well. And here are some regions that are very interesting on Mars. This is one we just talked about. The Tharsis Bulge is a very large feature. Olympus Mons is the largest volcano probably in the solar system. It's much larger than anything we have here. Over in here we have some other regions where we've sent some things to land. This is very small for me to read. It's okay. I'll get past it. But this is, I think, a very, very interesting thing. So it's very important to realize about what we have here on these. This Hellas Basin here. The reason it's blue is because it's a very deep light basin. It was probably an impact crater at some point. Called the impact crater. This what happened a long time ago. These regions here mean these are very, very deep. These are very low. These are regions where the air pressure on Mars could be higher. That's important. The northern hemisphere is rolling terrain. The southern hemisphere is heavily cratered highlands. The average is 5 kilometers above the northern hemisphere. The assumption is that the northern hemisphere is younger than the southern. That means there must have been lower elevation and was flooded with lava and other stuff back in the day. The day being a few billion years ago. Okay, here's a little trivia question for you that we don't always catch. You know, scientists are always coming up with fancy names with things. Well, one of the first probes, there were a couple of probes that were sent to Mars back in the day. One of them was called the Mariner probe. So this Valles Marineris nice Latin word. You'd think it was very old or had some exotic meaning. No, it's named for the Mariner probe that was sent to Mars. So it's the good name for it, or the good name I can pronounce well, is the Mariner Valley. So Mariner Valley is a huge canyon. That's the big thing about this. Here is the I guess it's created by crustal forces. Now there's crustal forces are not the same thing as plate tectonics because there's no plate tectonics on Mars. But it's about 4,000 kilometers long. If you see a picture of something that I've been to and I'm amazed that this is different, here's the Grand Canyon, and that's all of it. Look how large the Mariner Valley is and how deep a swath of material it is. It's huge. Why the hell did it get that way? I don't know. But it's interesting. And also, as I said a minute ago, the Mars has the largest volcano in the solar system. It's called Olympus Mons. It's about 700 kilometers in diameter at the base. It's about 25 kilometers high. And the caldera, which is this region around here, which is around the top, that is 80 kilometers in diameter. There were 3 other Martian volcanoes, and they're only a little bit smaller. So there was a lot of volcanic activity on Mars, which is interesting considering its lack of interior activity undergoing inside it. There was one time probably on water on Mars. I had been skeptical of this, but that's just because I was kind of ignorant of it. I think there probably was, and it gives the mechanism here that we'll talk about maybe next week about how this whatever happened to the water on Mars. And I'll keep going here. Now these remain some of my favorite pictures, and I like these. The ones in our current book are good. This I got used to, and I like this better. But again, the information here about the atmosphere is very, very, very important. First of all, if you look at the temperature, you can see if we say remember 300 degrees Kelvin was a nice day on the Earth. Nice day on Mars can't get can't get above 250, so it's very cold. It's 50 degrees colder on Mars than it is on the Earth on a good day. There is the altitude. That's like at sea level. Now these numbers over here are very important for the existence of water. This is 10 to the minus 3 at the surface of Mars. That means that the atmospheric pressure on the surface of Mars is 1,000 times less than it is on the surface of the Earth. It's almost a vacuum. It's very, very thin. So the idea of going to Mars, like people have talked about, and just jumping around, wrong. It won't ever happen because the atmosphere is too thin. Fog can form in low-lying areas as sunlight strikes. This fog here is probably carbon dioxide because that can form that. Mars can be, everything is a victim of greenhouse gases. It says, but this has in the opposite sense. This makes me think sometimes that maybe the greenhouse effect and that effect ongoing on planets may be a natural thing. We had the greenhouse effect on Venus. There was never any industry there. We have the greenhouse effect on Mars. Never any industry there. We have the greenhouse effect we worry about here. I don't know if it makes any difference. But at any rate, as water froze on Mars, that means it took water out of the atmosphere. Mars became more and more reflective, and the atmosphere became thinner and thinner and thinner. So freezing more water eventually caused carbon dioxide out as well. So you have a very thin atmosphere made up of a little bit of carbon dioxide, not very much else. The atmosphere on Mars may have been thicker at one time with liquid water in the past, but it's now gone. The mechanism that by which it left, people aren't really sure about. I was skeptical it was there at all. I think it might have been there, like they say. They're smarter than I am. I don't know. Now this is important. Okay, there was no evidence of seismic activity on Mars, but at the time of writing this book, there hadn't been no sightings done. Or no seismic studies done. Some are underway now with very limited success. One of the things that I just recently read about was that the Martian soil is just very weird. Weird was a word that they were using in this article I read. And we'll discuss that some next week when I get back, because some of the tools they tried to use have been unsuccessful because they were assuming the soil on Mars was like it is on the Earth, and it's not. Don't know why. Don't know why at all. Uh, and also, more importantly for humans, there is no magnetic field on Mars either. Magnetic field, as I'll tell you when I get back, is very important for life to exist on Mars, and we'll talk about that some more next week. Let's see what else have I got. Do I have more? Yeah. Oh yeah, this is important. It's because we have Mars has two moons. They're both very small, and one's called Phobos and one's called Deimos. And one was probably captured. It was probably an asteroid that was captured as it flew by. Phobos may have formed when Mars was struck by another meteor or another asteroid and bounced off, and this was debris from that. And so we'll talk about that some more as well. But there is some interesting forces acting on those as well. And I think that is all I've got for you right now. Okay, cool. All right. So anyway, this is a couple of very long videos for this little tool I've got, but I hope to see you on Monday in class. Have a really good Thanksgiving, and with any luck, I'll be back there with bells on Monday. So have a really good day and a good Thanksgiving, and I will talk with you soon.